If alpha and beta are the zeros of the quadratic polynomial f of t is equal to t square minus 4t plus 3, find the value of alpha power 4 beta cube plus alpha cube beta power 4. So in this question, first we need to find the sum of the zeros and product of the zeros. So this is the given polynomial t square minus 4t plus 3, and we know from the relation between the zeros and the coefficients of a quadratic polynomial that the sum of the zeros alpha plus beta is equal to minus coefficient of t divided by coefficient of t square. So in this case, alpha plus beta will be equal to minus of minus 4 divided by 1. So sum of the zeros will be equal to 4. Next, there is a second relation is product of the zeros is equal to constant by coefficient of t square. So that will be equal to constant term in this polynomial is 3 and coefficient of t square is 1. So product of the zeros is 3 and sum of the zeros we found out to be 4. Now we can find the value of alpha power 4 beta cube plus alpha cube beta power 4. Now in both these terms, alpha cube and beta cube are common, so we can take that outside. So alpha cube beta cube into alpha plus beta. Now this can be written as alpha beta whole cube into alpha plus beta. Now we can substitute the values of alpha beta and alpha plus beta. We will get 3 cube into 4. 3 cube is 27 times 4. 27 times 4 is 108. So the answer to this question is 108. Now the next question, similarly we have been given a quadratic equation and we need to find the value of alpha by beta plus beta by alpha. So similar to last problem, we can use the relation f of x is equal to 6x square plus x minus 2, and we know from the relation between the zeros and coefficients of a quadratic polynomial that alpha plus beta should be equal to minus coefficient of x by coefficient of x square. So in this case, sum of the zeros will be equal to minus coefficient of x is 1 and coefficient of x square is 6. So we found the sum of the zeros value. Now the product of the zeros should be equal to constant term by coefficient of x square. So in this case, that will be minus 2 constant divided by coefficient of x square is 6. So the product of the zeros is minus 1 by 3. Now we can find the value of alpha by beta plus beta by alpha. Alpha upon beta and beta upon alpha is equal to, by cross multiplying these terms, I'm getting alpha square plus beta square divided by alpha beta. This term we can substitute the value, but alpha square beta plus beta square is not in the required form, which is alpha plus beta. You know the algebraic identity that a plus b whole square is equal to a square plus b square plus 2ab. So this is an algebraic identity. If we take this 2ab to the left hand side, then we will get a plus b the whole square minus 2ab equal to a square plus b square. So using this, instead we can substitute the value of alpha square plus beta square as alpha plus beta the whole square minus 2 alpha beta divided by alpha beta. Now let us substitute the values of alpha plus beta and alpha beta. alpha plus beta is minus 1 by 6, alpha beta is minus 1 by 3. So minus 1 by 6 whole square minus 2 into minus 1 by 3 divided by minus 1 by 3. Minus 1 by 6 whole square is 1 by 36 minus into minus will become plus. So plus 2 by 3 divided by minus 1 by 3. So this term, which is 1 by 36 plus 2 by 3 divided by minus 1 by 3. We need to cross multiply once again. We can multiply this term with the 3. So 3 by, no, we don't need to multiply this term. 1 by 36 plus, we can convert this term into 36 by multiplying it with 12. So we multiply 12 in the numerator and denominator. So 12 times 2 will become 24. 12 times 3 is 36 divided by minus 1 by 3. Now they are having common denominator. So we can write this as 25 divided by 36 into, since this is in the denominator, we can multiply it as the inverse. So 3 by minus 1. This 3 will get cancelled with 36 and we will get 12. So the final answer will be minus 25 divided by 12. This is the required answer. If you have any doubts in these two questions, feel free to discuss in the comment section. Thank you.